So we're starting with Suvat in one dimension, and we're not going to do the velocity time graph, we're just going to do A and B. The formula, remember, are on the formula sheet. Hello.
Do you have a spell maths book? Hello.
There's a couple.
Thank you.
No trouble. But I will put the key formula. So if you're, I'm going to put it on this side of the board. So if you're watching at home, you won't be able to see it, but hopefully you can dig it out in your formula book. But you know, I'm pretty sure that today we won't need anything other than those three formulas. So I'm just going to let you have a go at this one. Yes, 9.8. Part A, you don't need to work out how long it takes to go up and then how long it takes to go down. You can just say, when will S equal minus 32? That's assuming we consider up to be positive, which I am. I thought Jacob was going to come to this one. Are you at home, Jacob? You should be here. Obviously, when you square root, the will be negative, but actually it says the speed, so that really doesn't have a direction involved, so it'll just be the size of that speed. I suppose that's too significant figures. I need to double check that level of rounding. Now, more than 40 actually means 8 metres above where it started. So when we ask when does S equal 8, we're asking when is it up here, and obviously it's going to be there at 2 different times. So the 2 different answers we get from that quadratic will be the time when it gets up there and the time when it goes down. How long it is above is the difference between those 2 times, which I'm hoping that your calculator will give you. Remember, we're not doing the sketch of the graph. We do have this problem, don't we? The answers are in the equation solver and we need to get them out, so I would just write them as accurately as I can. I suppose you could use the surd version to get that answer.
Well, at least I'm thinking it's half the problem, right? Well, at least you're finishing.
Just give me 1 more minute and then we'll move on to 2 dimensions.
Oh, lovely. It sounds like you're actually. Yeah, thank you.
So you get 3.8-ish and 0.4-ish, which give you a difference of 3.4-ish. Please don't be that inaccurate in the rule. Now, you know, that's obviously AS is still on the A-level syllabus. I'd like to say it will come up. I suspect it won't, but you know, it's worth remembering as part of our revision. Any questions about that? Let's move on to 2 dimensions then. So this was the stuff that I covered over Easter, and I sort of hope, although we did do a little bit of it in class previously, I do sort of hope that you've engaged with those videos. If you haven't, they're there online, and you know, I heartily commend them to you because they're really worth doing. I've just realised I've left my squirty bottle in the other room. So the key thing I think here is that we understand the words used. So this ball is being projected at an angle, and its speed is the magnitude at which it's going. So there's no reference to its direction. So it's being projected with a speed of u meters per second. So speed is the hypotenuse. It's the size. There's no mention of the direction. Velocity, well, velocity has an aspect of direction in it, and when we're dealing with things moving at angles, the good news is that we can deal separately with horizontal and vertical movement. So we can think vertically, and the vertical component of that speed, well, I know that angle is 45, so that's u cos 45. So that's its vertical velocity. And I can do Suvat vertically. So I know that vertically its initial velocity is u cos 45. The acceleration, well, if up is positive, that's just the same. I don't need to consider the horizontal movement at all. I can do the same horizontally. And because of the assumptions we make, this is even easier because there's no acceleration horizontally. So that means the horizontal component of its speed will be u cos 45. Yeah, it's an unusual answer because it's a question because they're both 45. And it's going to stay at that. We are modelling this without any resistance, friction, spin on the ball or whatever. So acceleration is 0. So its horizontal speed is always going to be that level. Okay, so we are told that the ball hits the ground here 100 metres away. So there's 2 bits of information that I know there. I know that after this time, and we're not told the time, are we? We're not told the time? No. After this time, let's call it t, it's moved 25 metres down. So let's say t equals t. It's moved 25 metres vertically, and it's moved at the same time, it's moved 100 metres horizontally. And that allows me to write 2 equations which I can then solve. This problem doesn't involve v at all, so it almost certainly is going to involve this equation. So go on, see if you can get somewhere with writing the 2s equals ut plus a half at squared equations, one for the vertical movement, one for the horizontal movement. We don't know the time, so we're just going to call it t. And what we're trying to work out is u. 2 missing values, t and u, 2 equations. We should be able to do it. So see if you can do that. S equals ut plus a half at squared for both of those motions, horizontal and vertical.
I'm following you.
That's 6 marks. So, you know, there's quite a lot of work involved here. There's a couple of ways I could go. If I wanted to find t, then I could rearrange this to say u cos 45 equals 100 over t and substitute that into there. I don't want to find t, I want to, I want to find u, don't I? I want to find u. So I'm going to rewrite this as t equals and I'm going to substitute that in to this equation. So I'm going to put it in here, and I'm going to put it in here, remembering that I've got to square it, and t squared will be 100 squared over u squared times, times cos 45 squared. Okay, so this is fiddly algebra, but see if you can do it. Write that equation again, replacing t here with that and t squared with that. I should really write that as cos squared 45, shouldn't I? It's the same thing. I can work it out. That's the key thing. I can work it out. Yeah.
Where did you get u from? Like u cos 45.
So we're told the initial speed is u.
Oh, right, okay.
So its vertical component is u cos 45. Its horizontal component is also u cos 45. So that's the initial speed in both the horizontal and the vertical direction.
Yeah.
Because a is 0, that term just disappears. So that's why this horizontally everything is so much easier. Rewrite that as t equals, substitute that into here. It's fiddly, but of course we know what g is, we know what sine 45 is, we know what cos is, we know what everything is now apart from u. And square root that, and you should get, and it was a show that question. So to show that it was 28, and we did. So fiddly algebra, but it's all based around this idea of dealing with horizontal and vertical separately, and the horizontal being so much easier because there's no acceleration. So the distance horizontally this is just speed is distance over time, so distance is speed times time. I mean it's it's a special case of that formula there. We'll only do the next bit. The greatest height of the ball above the horizontal ground. So this is something which applies to both 2D and 1D. When it reaches its greatest height, what do I know about its motion at that point then? What do I know about the motion of the ball?
0.
What specifically, what is 0? So in which direction? Vertical or horizontal? Vertical, that's right, yeah. So part B is a vertical question, isn't it? So I can, for part B, I'm looking at the vertical side of things, and I now know what U is. U is 28, we just worked it out. So my initial velocity vertically is 28 times cos 45, and I'm asking when is it equal to 0? That's what happens when it reaches its greatest point. And this is true in one dimension as well. So to work out its greatest height, we ask when's the velocity 0, and we want to know the actual distance. So we're going to work that one out. So no t involved. So this is the formula that we need to use. These are all on the formula sheet, obviously.
So we'll just put some water over
Yeah, sure. Just go on in.
Have a good weekend.
Max, off you go.
Remember, vertically, if we're saying up's positive, acceleration is going to be negative. So you should get 45. The rest of that question, and this comes from the folder of resources. I'll remind you how to locate that in just a second. And this is Mechanics Topic Test 3. And you might want to do another one. This was question... So that was question 4. Topic test 3, question 2 is another good one to try. The question went on to say, if you take air resistance into account and it still lands at the same spot, what does that mean about the initial velocity? Well, if air resistance is going to slow it down, so if it's still going to reach the same distance, the initial velocity must have been bigger than 28, sorry, the initial speed. And then it says, one of those frustrating one-mark questions, how can you make this model more realistic, as well as adding in air resistance? So, you know, the effect of the wind, more accurate value of G, spin of the ball, size of the ball, etc., etc. Okay. So yeah, just let me remind you where to find those questions. All the questions are there. I hope you don't need a reminder, but there we go. We'll remind you all the same. So we're in OneNote, formula books under documentation, but I hope you're spending a lot of time in this area. And so we will go to exam board resources here. That's the folder. You can see that if you're trying to find a particular topic, look in the content list. But I've just told you it's mechanics topic test 3, so you can find it there in either PDF or Word form. Frustratingly with these, unlike the links PDF, which have the mark schemes immediately after each question, with these you have to go to the end, but you're smart people, I'm sure you can work it out. Okay, so I'm now going to move to topic test 1, because we're going to talk about vectors now. And I'm going to do question 4 from topic test. When I say to question 4, I'm talking about this question. This is the question number I was referred to in the mark scheme. That's just the question from the paper it originally came from. 2, 3. Okay, so an alternative way of describing two-dimensional motion is to describe the horizontal and vertical components in one go, and that is what a vector provides us with. So if we look at our Suvat statement, displacement can be a vector, because you can, in 2 dimensions, you're moving in this direction and this direction. So this is a vector. Velocity is a vector. We have the horizontal and the vertical components, initial and current velocity. Acceleration is a vector, because you can be accelerating so much in this direction, so much in that direction. The only one up there that isn't a vector, we call it a scalar, is time. So in this question, we've got a particle moving with constant acceleration of 2 minus 3. That means its acceleration is 2 meters per second in that direction and 3 meters per second in that direction. So if it asked for the magnitude of the acceleration, it would be the hypotenuse. But I'm going to do it in my Suvat thing, because we can use these equations with vectors. So we've got the option of going separately, horizontally and vertically, or we can do it in one go using vectors. So that's, you know how I like columns. You can, if you prefer the IJ notation, fine. At time t equals 0, the initial velocity is just 4I, which is...
Go back to left because you've been removed. Go and sit and do what you've asked.
And we want to know the velocity after 2 seconds. So when we apply our formula using vectors, we don't have to write a separate one for horizontal and vertical. We just use the appropriate formula, plugging in vectors for u, v, s and a. T will just be a number. So I want to know, what do I want to know? The velocity. So I want to know this value here. So let's call it something. So no mention of displacement here, so I'm going to use v equals u plus at. And I'll just use the vectors. I'm going to put the 2 in front of the vector. And although we're writing it as a single equation rather than 2 separate horizontal and vertical equations, you deal with it as separate. So we do 4 plus 2 times 2 and 0 plus 2 times minus 3. Can I get you to tell me the speed at 2 seconds as well, even though it doesn't take, can you tell me the speed at 2 seconds? We've worked out the velocity, and I guess because they've used IJ notation, I ought to give my answer. Can I get you to work out the speed and the direction in which it's travelling at that point?
Is it not 8?
Oh, what have I done?
And
Please, Morris.
Thank you. I did that on purpose.
Berlin could be, but what is it? The fall of the Berlin Wall? Is it something to do with the rise of Nazi Germany? What are we talking about? What exactly? What is it? I'm thinking you at lunchtime. I am. Tell me what it is about. I'm coming to see you at lunchtime.
So the speed is 10 meters per second, and it's travelling at an angle of 36.9 degrees below the horizontal. And we just need to make sure in any question, I mean this doesn't ask for it, this is just adding on, but in any question that asks for an angle of travel, that we are careful that we're doing it in the way they want. If it's the bearing, then that would be 90 plus that, or it might be the angle with the vertical, or the wording varies. Go on, see if you can do the second question, part B. S is the displacement, how far it will have travelled from the start. So I'm not putting 1, 1, which is its position. I'm going to work out its displacement in those first 3 seconds and then add that onto 1, 1. So I'm going to work out the displacement as just a vector on its own. I'm not going to use this initially. I'm going to use that at the end when I've got my answer. So this is just how far has it travelled horizontally and how far has it travelled vertically since the start. So this answer here is how far it has moved from where it started. But it started at 1, 1. So its position relative to the origin will be 1, 1 plus how far it's travelled since it started. So it's actually travelled, although it's travelled 21 metres horizontally, it started 1 metre from the origin horizontally, so it's now 22 metres from the origin. This is 13.5, so it's 1 take away 13.5, so that's the position vector. I'm just going to check whether they included the units in the answer. I don't think they did, but we'll have a quick look. Question 4. They didn't include the units, but of course they originally phrased the question using I and J, so I needed to do that. Although you will note that the mark scheme says accept column vectors throughout, so you know that would imply to me that even if I left my answer in column vector form, that is okay. Never had enough time in this lesson, do we? Right. So the last one I want to try, we'll stick with vectors. We'll make a start on it, even though it's a bit of a nasty. Oh. So remember, I'm hoping that what we've done so far has sort of reminded you and hasn't been too tricky. So if we finish with a really tricky question, you know, don't be too down. But here we go. Here's O is the origin, and this position vector is just like a coordinate. So what we're saying is that in these first 2 seconds, its displacement is 7 minus 10. So see if you can Suvat this problem up for that first 2 seconds. So make t equal 2. See if you can fill in the other bits, and then see if you can work out the acceleration. We're to show that, so we've got to show that the magnitude of acceleration, which is the hypotenuse, is 2.5. So see if you can Suvat that bit up. You okay? Did it strike anyone? Thank you. Thank you. That was me. I'd almost certainly need to visit the toilet. Big shock. Velocity. So I don't know the acceleration, so I'm going to use to work out the acceleration. That will give me it in vector form, so I'll need to work out the hypotenuse in the hope that I get 2.5 as my answer. So you should get 1.5 minus 2, which when you Pythagoras that up, gives you a magnitude of 2.5. If you're ahead of me, could you work out its speed after 2 seconds? So could you work out its speed after 2 seconds? We now know its acceleration. So some of you will be ahead. If you could work out its speed after 2 seconds. Sorry, I'm inevitably skipping along. So we've worked out the acceleration in vector form, and using Pythagoras confirmed that we get 2.5 as its magnitude. I then said, although it doesn't say, can we work out the speed at the end of that period, which I used v equals u plus at, so u plus 2 lots of a gave me that. Because this is a two-part journey. So we've got the first 2 seconds take us from the origin to P. We then carry on moving. So we reset at this point and say, okay, let's now set the clock to 0. So the speed at the point it reached P is now my initial, the velocity is now my initial velocity. The acceleration changes, still constant, and of course Suvat only works with constant acceleration, so it's now 8.8. Yeah, right. And we're told that at this point the direction of motion is northeast. The direction of motion is northeast. And we're asked to find time. And there's a subtle trick here that we need to be able to work out in order to answer this question. Can anyone tell me what I know about its speed as a vector if it's travelling northeast? I've got two numbers here. It's horizontal and its vertical component. They are the same. If it's travelling at 45 degrees, then this and this will be the same. So I'm going to call them both x. Now I want to know what t is, so I'm going to use v equals u plus at. Remember, u is the initial velocity because that's the speed it reached. And at this point, I'm going to, well, no, I'll tell you what, no, so what we're saying is that this is actually going to be 5 plus 4 lots of t, and this will be minus 7 plus 8.8 times 2. But, as Pat pointed out, if it's travelling in that direction, those two components will be the same. And forgive me for rattling through this, but I can take away 4t from both sides, add 7 to both sides, and work out the value of 2. So that was a nasty sort of one of those subtle questions where you had to spot the trick. But of course now we've done that trick, we know that one. And of course if it had been travelling southwest, then that would have been the same. Southeast, they would have been the same, except one would have been negative. So you could imagine how that same question could crop up in a variety of ways, some harder than others. Suvat, there we go.